Hello everyone. Welcome to the new session on Informatics and Introduction to Bioinformatics. Knowledge Skills for Higher Education Part 1. We frequently hear the words data, information and knowledge used as if they are the same thing. Firstly, let's look at knowledge. Knowledge is what we know. You can't currently store knowledge in anything other than a brain, because a brain connects it all together. Everything is interconnected in the brain. Computers are not artificial brains. They don't understand what they are processing and can't make independent decisions based upon what you tell them. There are two sources that the brain uses to build this knowledge: information and data. The following model, as you see in the figure, explains how these interact. Data. All software is divided into two general categories: data and programs. Data are the distinct pieces of information, usually formatted in a special way, and the programs are collections of instructions for manipulating data. Data can exist in a variety of forms, as numbers or text on pieces of paper, as bits and bytes stored in electronic memory, or as facts stored in a person's mind. That is, data is represented with the help of characters like alphabets A to Z, digits 0 to 9, or special characters like plus, minus, slash, star, less than, greater than, equal to, etc. The term data is often used to distinguish binary machine readable information from textual human readable information. For example, some applications make a distinction between data files, that is files that contain binary data, and text files, that is files that contain ASCII data. Hence, data can be defined as a representation of facts, concepts or instruction in a formalized manner which should be suitable for communication, interpretation or processing by human or electronic machine. Information. Information allows us to expand our knowledge beyond the range of our senses. We can capture data in information and then move it about so that other people can access it at different times. Information is organized or classified data so that it has some meaningful values to the receiver. It is the processed data on which decisions and actions are based. For the decisions to be meaningful, the processed data must qualify the following characteristics. Timely. Information should be available when required. Accuracy. Information should be accurate. Completeness. Information should be complete. Data processing cycle. Data processing is a restructuring or reordering of data by people or machine to increase their usefulness and add values for particular purpose. Data processing consists of basic steps: input, processing and output. These three steps constitute the data processing cycle, as you can see in the figure. Input. In this step, the input data are prepared in some convenient form for processing. The form will depend on the processing machine. For example, when electronic computers are used, the input data could be recorded on any one of several types of input medium, such as magnetic disks, tapes and so on. Various methods to input the data. Some input data can go directly to the computer for processing. Input in this category includes barcodes, speech that enters through the computer through a microphone, and data entered by means of a device that converts motions to on-screen action. Some input data, however, goes through a good deal of intermediate handling, such as when it is copied from a source document and translated to a medium that a machine can read, such as a magnetic disk. In either case, the task is to gather data to be processed by the computer, sometimes called raw data and convert it into some form the computer can understand. Keyboard. In computing, a keyboard is a typewriter style device which uses an arrangement of buttons or keys to act as mechanical levers or electronic switches. While most keyboard keys produce letters, numbers or signs, other keys or simultaneous key presses can produce actions or execute computer commands. Mouse. A mouse is an input device with a ball on its underside that is rolled on a flat surface, usually the desk on which the computer sits. The rolling movement causes a corresponding movement on the screen. Moving the mouse allows you to reposition the pointer or cursor as an indicator on the screen that shows where the next interaction with the computer can take place. The cursor can also be moved by pressing various keyboard keys. You can communicate commands to the computer by pressing a button on top of the mouse. In particular, a mouse button is often used to click on an icon, a pictorial symbol on a screen. The icon represents a computer activity, a command to the computer. So, clicking the icon invokes the command. Trackball. A variation on the mouse is a trackball. You may have used a trackball to play a video game. The trackball is like an upside down mouse. You roll the ball directly with your hand. The popularity of the trackball surged with the advent of laptop computers when traveling users found themselves without a flat surface on which to roll the traditional mouse. Source data automation. Collecting data where it starts. Efficient data input means reducing the number of intermediate steps required between the origination of data and its processing. This is best accomplished by source data automation. The use of special equipment to collect data at the source as a byproduct of the activity that generates the data and send it directly to the computer. Recall, for example, the supermarket barcode, which can be used to send data about the product directly to the computer. Source data automation eliminates keying, thereby reducing costs and opportunities for human introduced mistakes. Since data about a transaction is collected when and where the transaction takes place, source data automation also improves the speed of the input operation. Magnetic ink character recognition, MICR. MICR is a method of machine reading characters made of magnetized particles. The most common example of magnetic characters is the array of numbers across the bottom of a personal check. Most magnetic ink characters are pre-printed on your check. If you compare a check you wrote that has been cashed and cleared by the bank with those that are still unused in your checkbook, you will note that the amount of the cashed check has been reproduced in magnetic characters in the lower right corner. These characters were added by a person at the bank by using a MICR inscriber. Voice input. Does your computer have ears? Speaking to a computer, known as voice input or speech recognition, is another form of source input. Speech recognition devices accept the spoken word through a microphone and convert it into binary code that can be understood by the computer. Touchscreen. One way of getting input directly from the source is to have a human simply point to a selection. The edges of the monitor of a touchscreen emit horizontal and vertical beams of light that crisscross the screen. When a finger touches the screen, the interrupted light beams can pinpoint the location selected on the screen. Processing. Data processing is the collection and manipulation of items of data to produce meaningful information. For example, paychecks may be calculated from the time cards, or a summary of sales for the month may be calculated from the sales orders. Data processing consists of three basic activities: capturing the input data, manipulating the data, and managing the output results. Capturing the input data. Data must be recorded or captured in some form before they can be processed. Data is first recorded on source documents, paper forms designed to accept input data, or they may be captured by keyboards, automated teller machines, or other direct input devices that accept input data in a paperless, machine readable form. Manipulating the data. The available data is subject to one or more of the following operations: classifying, calculating, sorting, summarizing. Managing the output results includes sorting, retrieving, communicating, and reproducing. Output. Output is data that has been processed into a useful form called information. The particular form of the output data depends on the use of the data. For example, output data may be paychecks for employees. Common types of output are text, graphics, audio, video, etc. Text consists of characters, which may be letters, numbers, punctuation marks, or any other symbol requiring 1 byte of computer storage space that are used to create words, sentences, and paragraphs. Graphics are digital representations of non-text information such as drawings, charts, photographs, and animation. Audio is music, speech, or any other sound. Video consists of images played back at speeds to provide the appearance of full motion. An output device is any computer component capable of conveying information to a user. Knowledge management. In our daily life, we deal with huge amount of data and information. Data and information is not knowledge until we know how to dig the value out of it. This is the reason we need knowledge management. Knowledge management refers to a multidisciplinary approach to achieving organizational objectives by making the best use of knowledge. Knowledge management focuses on processes such as acquiring, creating, and sharing knowledge and the cultural and technical foundations that support them. Knowledge management may be viewed in terms of people. How do you increase the ability of an individual in the organization to influence others with their knowledge? Processes. Its approach varies from organization to organization. There is no limit on the number of processes. Technology. It needs to be chosen only after all the requirements of a knowledge management initiative have been established. Culture. The biggest enabler of successful knowledge-driven organizations is the establishment of a knowledge-focused culture. Structure. The business processes and organizational structures that facilitate knowledge sharing. Knowledge management draws from a wide range of disciplines and technologies. Cognitive science, expert systems, artificial intelligence, and knowledge-based management systems or KBMS. Computer-supported collaborative work, library and information science, technical writing, document management, decision support systems, semantic networks, relational and object databases, simulation, organizational science. Although around 20 kinds of disciplines and study areas were listed above, there is no way to include all of the related subjects to knowledge management. The history of knowledge management. In 70s, a number of management theorists have contributed to the evolution of knowledge management. Peter Drucker, Information and Knowledge as Organizational Resources. Peter Senge, Learning Organization. Leonard Barton, well-known case study of Chaparral Steel, a company having knowledge management strategy. 80s. Knowledge and its expression in a professional competence. As a competitive asset was apparent. Managing knowledge that relied on work done in artificial intelligence and expert systems. Knowledge management related articles began appearing in journals and books. 90s until now, a number of management consulting firms had begun in-house knowledge management programs. Knowledge management was introduced in the popular press. The most widely read work to date is Ikujiro Nonaka's and Hirotaka Takeuchi's the knowledge creating company, how Japanese companies create the dynamics of innovation in 1995. The International Knowledge Management Network, or IKMN, went online in 1994. Knowledge management has become big business for such major international consulting firms as Ernst & Young, Arthur & Anderson, and Booz Allen and Hamilton. E-learning. As the economy becomes more global and the use of PCs more pervasive, there has been a dramatic increase in e-learning, also known as computer-based training. E-learning is closely linked to and overlapping with but not equal to knowledge management. E-learning can be an effective medium for knowledge management deliverables. The value of knowledge management. Some benefits of knowledge management correlate directly to bottom line savings, while others are more difficult to quantify. In today's information-driven economy, companies uncover the most opportunities and ultimately derive the most value from intellectual rather than physical assets. To get the most value from a company's intellectual assets, knowledge management practitioners maintain that knowledge must be shared and serve as foundation for collaboration. Yet, better collaboration is not an end in itself. Without an overarching business context, knowledge management is meaningless at best and harmful at worst. Consequently, an effective knowledge management program should help a company do one or more of the following: foster innovation by encouraging the free flow of ideas, improve decision making, improve customer service by streamlining response time, boost revenues by getting products and services to market faster, enhance employee retention rates by recognizing the value of employees' knowledge and rewarding them for it, streamline operations and reduce costs by eliminating redundant or unnecessary processes. These are the most prevalent examples. A creative approach to knowledge management can result in improved efficiency, higher productivity, and increased revenues in practically any business function. Let us now summarize what we have learned in this session. The words data, information, and knowledge are often used interchangeably. In fact, they are similar concepts but with some key differences. The terms data, information, and knowledge will be defined in order to compare and contrast them and show the unique role they play in processing information. Data are the raw isolated facts, figures, images, and sounds that have little or no meaning. Information, therefore, is data that is summarized or presented in a useful or meaningful way. Knowledge is usually equated with the best way to interpret facts and use information. Hence, data processing is the collection and manipulation of items of data to produce meaningful information. Knowledge management is a collection of processes that govern the creation, dissemination, and utilization of knowledge. Many large companies and non-profit organizations have resources dedicated to internal knowledge management efforts, often as a part of their business strategy, information technology, or human resource management departments. Several consulting companies also exist that provide strategy and advice regarding knowledge management to these organizations. The following are some questions for you to work out. 1. Differentiate between data, information, and knowledge and provide an example to illustrate the differences. 2. Explain knowledge management today and the future. 3. What are the challenges of knowledge management? 4. Assess the differences in the management of knowledge from ancient to modern times. The following are some journals and websites for your reference. Conceptual Approaches for Defining Data, Information and Knowledge by Sin C in 2007, Journal of the American Society for Information Science and Technology. The websites for your reference are www.infoengineering.net, www.tutorialspoint.com. Thank you for watching this session. See you next time. Until then, bye.